And I hope you can all see the screen, the presentation, so that we can just continue. Okay, let's continue where we left off last time. I think more people will hopefully still join, but that is also okay. Okay, so last time we looked at nearly the first part of your exam prep, and today we will just continue with that. It's a previous exam paper of June 2020. So let's go into this. So as we saw in the week, how they jump between sections. Now suddenly we nearly back to the start of your study guide, where we're now looking at simplifying the expressions. So again, just to note for your exam as well, you can download the paper and you can work through. So the things that you feel are easier for you to do first, please do that. Okay, so let's look at this, and let's see how we can simplify this. So I will first really work with a one term, and then with the other term, and then we can multiply again to see what we get here in the end. Okay, so the first one that I'm going to do is work with this. So to put it in a different view for myself to work with, I can say, well, there's a -4, there's a 4, so that is actually -4 divided by 4. So x to the power of -4 divided by 4. Then we sit here with y to the power of 3/4. Okay, so all that I did is I brought that 4 into the equation every time. So to simplify that, at this point I can't do really anything else with this. I could maybe have simplified that to -1, but let's first see what we have on this side. Okay, so square root of 4 is 2. Okay, so that already tells me I will probably only looking at those three answers where I have a 2 in them. So that one I will already cancel out. X to the power of 2, if I take the square root of that, it becomes, so we can, let's do that, x divided 2 by 2, and then y, I first bring up y to the top, which is y to the power of 4, and then if I square root it, I will just divide it by 2. Okay, so now we can at least simplify. So let's do it. That one would have been -1. Nothing we can do there. We bring the 2 to the front. X to the power of 2/2 is 1. And y 4/2 is 2. So then that and that will cancel out, because -1 plus 1 is 0. X to the power of 0 is 1. So we are left with 2 times y. That I will rather, if we see that we need to nearly change it, let's change it. So that is, if I put it over 4, it will be 8 over 4. So let's do that. So 3 times 4, 3 plus 8, sorry, 3 plus 8 is 11 over 4, which will give you option 4 as the correct answer. I would, in the exam, nearly have seen or looked at that as an option, because the first option was 4y to the power of 1 over 4, or 11 over 4. So it nearly tells me you want to look between the two that are very similar. But still, I think the easy process, if you just follow the rules to nearly simplify the expression. Okay, happy with this kind of thing. You will definitely in the exam get something like this. So okay, let's go to the next one. Now it becomes a little bit more difficult. So here they ask us, a virus is thought to spread through a game reserve impala population according to this equation, where n is the number of impala infected after T days. Approximately how many days are 200 impala infected? Okay, so n is the number of impala, T is the days. So what we need to do here is, again, we need to simplify the expression, and they give us a bit of information. So they tell us n is 200. So we can say 200 is equal to 125.5 e to the power of just precise right again, e to the power of 0.12 t. Okay, so this basically tells me that somewhere I will probably need to, when I work with E, I probably need to do a log transformation on it, unless your calculators are also equipped to do that. But first, let's just simplify. So I will first get rid of the 125.5. So 200 divided by 125.5 will give me E equal to 0.12 t. So then we need to check what is 200 divided by 125.5. Wait, I've got 200 divided by 125.5. Okay, so that is 1.5936. Okay, so let's just do that. And then out of your, what was that? There was laws of log and things like that in chapter 2 or 3, if I can remember. Um, so now you need to basically, to get rid of the E, we say lin or log on both sides. And if we then take that log, let's just make sure I get 0.466. If we need to divide that by 0.12, it goes again. I still don't know why my screen actually does that. So divided by 0.12 will give you t is equal to 3.88. And they tell us that approximately how many days, so we will round that up to the nearest day, which will be 4, which is option 3. Okay, so with this one, nearly there's nothing that sometimes one thinks that you suddenly now need to do integration or any of those rules. Nothing like that you need to do, but you need to simplify. And by simplifying the E, you nearly need to remember the rule with that. So to get rid of the E, you need to take the log on both sides. So what that would have looked like in actual fact is you will take the log of the one side that we had in here, then we will say log of E to that, and log of E to that, basically that goes in front of there and that disappears. So that is how it would have happened that you get to that. But that you don't need to know. You just need to know if I log of E whatever to the power, that becomes the one that you will look at. Okay, so again, nearly this is around chapter 2, 3. It looks very complicated, and I think where a lot of and the first time I also looked at it, I was like, okay, but this tells me nearly I need to do something else with it. And I looked at it, and when I wanted to do integration, and I'm like, no, no, no. But then I'm just making it much worse for myself. Um, so it is actually just a, basic expression that you need to simplify. Okay, questions around this one. So you will see that you nearly get a few different forms of simplification. And they don't always need to tell you that you're simplifying something. Here, they could have just told you to simplify it and have replaced the n by the 200. You would have done exactly the same then. So again, just be nearly cognizant of what they nearly want to ask you in the question. Okay, and then as we have now seen, now they jump to linear programming again. So so now I go back to linear programming. So again, if a paper is like your mock exam that you can see all the questions, I would I would do all my linear programming together. I would do all my simplification things together. I would nearly do all those things in a row that you nearly don't need to jump between the questions. Again, just to make it simpler for yourself. But okay, so let's look at this one and let's see what they are telling us. So they talk about a small ironworks manufacturer is manufacturing two types of gates. So the one gate is security gate, the other one is or, or ornamental. Um, and then there is times required for each stage. And what do they tell us more? The limitations on available hours and the selling price per unit are given in the following tables. Okay, so hours available for welding, hours available for finishing. And then they tell us the security is X and the ornamental is Y. Okay, so the first thing I would nearly look at, and we've seen it with all our where they give us. Let me quickly go back to where was this. So with all of these ones, they give us a X and Y bigger than 0 because you're creating gates. You can't have a negative gate. You can't produce -1 gates or minus. Um, so all my values of X and Y must be bigger than 0. Okay, so look at that first one. Tells me it's going to be can be smaller than 0. Not going to happen. Okay, so nearly we could have eliminated that first option automatically because of the thing that we know. They don't need to tell us, um, but we know that we can't produce anything that is a negative value. You can produce 0 of something, which is fine, but you can't produce a negative value of something. Okay, so option 1, we already eliminated. What they then give us here is only the stages of production. So I won't be surprised if at a next question in my exam or things they also then ask you something about total revenue because of they give you the selling price. I don't think in this one they talked about it, no. So, but it can be a follow-up question because in here, nowhere else um, in the formulas they talk about the selling price component. So just it can be that they can ask you what the total revenue function is as well. Okay, and we can actually write it for you. So the total revenue would have been an easy one because it is the selling price of one product plus the selling price of the other product. So if you needed to add the total revenue curve with it or the equation, there it is. But okay, so let's look at welding. So for welding, we know it will take me 4.5 hours to weld X. It will take me 2 hours to weld Y. And I have basically 9 hours available. So I have exactly 9 hours available or less. I don't have more than 9 hours available. So if I look at my formulas, can't be because it needs to be less than. So where we already have eliminated another one. Okay, and then for the next one, finishing is 1x plus 2y, and that is also then smaller or equal to 400. Again, it's so weird. So again, we've got the one that says bigger, can't be. So the one that is left is the one that we're looking for. 4.5x plus 2y smaller or equal to, and x plus 2y smaller or equal to 400. So option 2 would have been the correct one. And if they ask or bring in the total revenue, you also can add the total revenue because it will be just for one times x and for other one times y. Okay, so just sometimes I bring in total revenue, sometimes not. Okay, any questions on this? So again, really looking at your linear equations, that's more in a table, not in any graph format. And if I ask you what is the set of equations that is possible. Okay, so let's go into I think, and this is Robin's nearly not 100% yet what you asked for last time about the turning points and stuff like that, but it is in working in that direction. So they give you some information, and with this information, you need to say what are the coordinates of a turning point. So I'm just gonna draw something here so you can see. So you've got both a positive, so somewhere here I can say it's a turning point. Oh, well, let's make it somewhere there. A negative and a negative will be there. Another positive. So it seems like the two areas where we're talking about the turning points is all both negative, and then it's exactly the same numbers, just negative, and then the same for. So we nearly gonna look for numbers that are very similar to this. So you look at the x value that is all going to be 0.5 or minus 0.5, and the y value that's a bit different, but the x's is basically gonna be a 0.5 value that we need to get. Okay, so they tell us the roots of a quadratic function are 2 and minus 3, and that the y-intercept is minus 6. Okay, so y-intercept minus 6. Okay, and they tell us the roots of that. So let's first work out. So we've got So if they tell us that the roots are 2 and 3, the one is 2, and the other one must be -3. Okay, so that is your roots are 2 and minus 3. Let's quickly see if we can put it here. 2 minus 3 and 2. So probably what would have happened is that it will look something like this. So what it so so that might be the one, but also if you look at it the other way around, see if you look at that, because that is the other one. Let me just draw this better. So if we wanted it to go this way around, oh, come on, you would see, so to go through those roots, but still you need to go through the -6. So there is no ways that you can draw that diagram with the positive values, because if your turning point is positive there and you've got those two roots that you need to go through, you can't also go through the -6 intercept. So that and that one will definitely not be able to do, because you will not be able to get your quadratic function to do that type of function. But let's quickly then solve this. So you sit with 2x, that is minus 2x, that's plus 3x, so 2x, so you get x to the power of 2 plus x minus 6, okay? So we know that at least what we did is right with the y-intercept as well. Now with the turning point, we know that we can use this formula, minus b over 2a. So again, that's a, that's b, that's c. So minus b is just -1 over 2a, which is just, again, 2 times 1. So x would be 0.5 minus 0.5. Okay, so there it's that one, or it's that one. And then just to make sure what y is, we put it into the formula back. So minus 0.5 to the power of 2 plus minus 0.5 minus 6, and that will then give you minus 6.25, which is that option 2. Okay, so in this instance, you could what I would have done, but okay, it's also I would have nearly liked to draw it, and just by doing those 3 points, you can nearly see something is weird here, that some of these points just can't happen. But yeah, so that is the way to work it out. They give you the roots, so you basically need to use those roots to set up your quadratic function. So that would have been your quadratic function. Then just remember that the standard quadratic function that we want to use when we look at the turning points, okay, it's actually plus c, so that would be your normal function. So then you can, to work out x for the turning point, you can put in that values. If you have it, you have your x, you put it back into your original so that you can get your y value as well. Because again, we've got from 0 minus 0, 0,5. So if you didn't draw this, you still would have had two options to pick out. So you needed to go to what your y value is. And then we would have seen it is the minus 6,25. Okay, questions on this one. So two other things nearly that I want to add for this one. It would not have mattered, but when the sign in front of your x square, so if it's positive, your you your graph is going up. So if it's positive before the x square, your graph is going up. If it's negative in front of the x square, your graph is going down. Okay, that's just so in here nearly I would have also seen, okay, but my graph needs to go up. If it then needs to go through those 2 points, if I even didn't know what your C value is, I know that the turning point will be at the bottom, which will also have nearly already said to me, okay, I can eliminate some of those options. If it was negative, then again, I would have said, oof, if I still need to go through those 2 points, it's negative, then it can only be one of those two that it can go through. So again, that can be used as a tip. So when positive, your arms is basically going up. When negative, your arms is going down. Okay, other questions that you might have on this one? Okay, so let's then just continue to cool to the next question. So now suddenly we're in demand again. Demand function of a firm is that, where P and Q represent price and quantity. At what value of P is marginal revenue equal to 0? Sure. Okay, so now they go from just that small function nearly, for you to go to marginal revenue. Okay, so first question nearly is marginal revenues equal to what? If you nearly can remember your formula. So not not need to put it into any of this, just if you need to work out marginal revenue, your marginal revenue is your total revenue that you nearly integrate. Differentiate, sorry. So remember that marginal revenue is your total revenue that you need to differentiate. So that now tells me, okay, they don't give me marginal revenue, but hey, maybe I can work out total revenue. Okay, and there was way back in this paper, there was also a question on total revenue. Um, so remember, total revenue is the original formula is price times quantity. And that's nearly why I also said in this one, remember total revenue every time, price times quantity. Okay, so we've got price times quantity. We don't know what, they don't give us a formula for price, so we just keep price as is. They give us a formula for quantity, so we can slot that into our function for Q. And then we need to multiply in. Okay, that is a bit, we just need to do that so that we can get to a function. So 60p minus 2p to the power of 2. Okay, so there's our total revenue curve. Okay, so then we need to differentiate that. So to differentiate that, remember there's 1, so it goes to the front. Then it is P1 minus 1, so it basically disappears. That goes to the front. 2 times 2.5 is 5. P2 minus 1 is then equal to 1. And that equals to 0. So 60 is equal to 5p, and then p is equal to 12. Okay, but let's see, what do they ask us? The demand function of a firm is Q, where that is at what value of P? Okay, so at what value of P is that equal to 0? So P is equal to 12. So they could have said at what value of P's marginal revenue equal to 60. So instead then of putting it equal to 0, you put it equal to 60. So we use this 0 in that instance. So whatever they tell you there, you can replace it in your marginal revenue formula. Yeah, so again, nearly, and I think this was chapter 7 and 8, where they talked about marginal revenue and how you get it from your total revenue. So again, they don't give you a lot of information. They only give you one of the functions, but nearly looking at this total revenue function, you can actually work out a lot. So again, I think, where was it? If we go back to the first, in the first view, there was also the supply. So I would again, if it was myself writing, I would nearly go through and check all the things that with demand and supply that is nearly similar types of questions and try to do that simultaneously, because then I think then it's also easier nearly to get into the rhythm and not be nearly catch off guard when suddenly there's another question about it. Okay, so questions around this one. Okay, I just hope is this at least helping you guys to nearly get ready for Tuesday, so that at least it is adding value. That for me is the most important, that it does make sense and help you. Okay, so let's look at the next one. Sure. Okay, so now we go to logs. We go to simplification. Yeah, so this is the interesting one. The log rules, I think it is chapter 1 or 2, or 3 might even be. So what would you do in this instance? So if we see that, and yes, it's going to look now that we are making this look extremely difficult, because it is going to look extremely difficult, because if I look at something like that, I would ask what the heck is going on. Um, okay, so from your log rules, log something minus log of another one. Basically, you can say log the first one divided by the second one. But this now looks very difficult, but let's just look at it without the log. So it is q divided by q over x plus 1. Okay, so q over 1 divided by q over x plus 1. So if we look at this, remember from ages ago, I don't know if it is still part of this, but from your maths from ages ago, when you have a divide, we can change it into multiply, but then we need to swap the, the fraction around. But now you can see if we have that, what we're left with is actually q plus 1. So the log, that now becomes something much simpler to work with. Okay, so now the other catch nearly is when we work with logs, there was a other one. Oh, where was that log? Okay, where it was log free, so we divided by log free. When you're working with, when they don't tell you what the log is, and that is exactly how your calculator sees it as well, is that is actually just want to, is that this is actually log to the 10, so log 10. Okay, so if there's nothing, it actually means log 10. And that is how your calculator is also programmed. So if we have log 10 q plus 1 is equal to 0.8, again, if you go and look at your log rules, we can get rid of that. How we do it is to say whatever that was to the power of 8.3. So we would have nearly added, so to get rid of that, we would have said we need to function it to that power. So if we would have now said bring that 10 in, it would have disappeared. But then the 10 needs to be on the other side as well. So now you can work with this. So Q is equal to 10 to the power of 0.8 minus 1 still, because that goes over to that side. If you work out 10 to the power of 0.8, you will get something like 6,31, and it goes on with more decimals. Look at there is an option for that, but remember there's for minus 1 still, so it needs to be 5.31, which there is an answer for that. If you set plus 1, there's an answer for it. Okay, so nearly if you set that answer that I got, there's your answer, there's the answer for it. If you added the 1, there's the answer for it. If you subtracted the 1, which is the right one, there's the answer for it. So again, it's one of those that in the exam, when you sit and you rushed for time, and suddenly as you go through and you work out something, you're like, oh, there it is already. And you forget that you need to do something more. It really, under stress circumstances, it really does happen. So just be very careful when you do this in the exam to make sure that your final answer is what you need to get to. Okay. Any questions around this one? So it looks very complicated. It looks even more complicated when you actually try to simplify it. But then in that simplification, when you actually really do that part on its own, it really simplifies it to make it easier. But at this stage, it really is a complicated formula that you need to work with. And I think that is nearly the thing, is to make that complicated equation a bit simpler for you. And is there any other ways how one can do this? Not really. I know in the first time I did this course, there was a guy that would have said, but let's just test the values and put the 5.3 in. And if I then get my answer, that is fine. So again, if you're in a situation like this, where you really don't know what to do, you have answers. Put that 5.3 in to the equation and see if it works out. It must work out. So again, if there is some of these things that give you, okay, that would have been, but where is some of these that, where was that other log one as well? Um, Now I'm jumping, sorry, to get to that log. That was probably the first one. Okay, so the same with this one. Um, you can, here we used a process, but you can check on your calculator to do that as well. You don't need to follow my process that I did here. The same if you don't know how to calculate with the logs, try to put in that final answer into the formula and see if it works. Really, it there is some other ways to get to it as well. Okay, so then we go to question 22. And this one is interesting as well. So how many units must be manufactured to maximize a profit defined by the function? Okay, so what must we do to maximize? What are we working out when we say we want to maximize a profit or when we want to minimize a profit? What are we working out? Okay, marginal revenue equal to marginal cost. Okay, yes, that is what we're doing. Um, is there a simple way of getting to that? So so we know this is negative. So Robin, what you are saying is 100%. So where that marginal revenue is going to be equal to marginal cost is at which point on this um, graph?
Right at the top.
Okay, right at the top turning point. So at your turning point, that is going to happen. Okay, so you don't need to go the route of trying to solve marginal revenue or marginal cost. You can just work out what the turning point is. So if you work out your turning point, your X and Y, you can get it. Okay. And we can work it out with this formula. So we know that the X for the turning point is that formula of minus B over 2A. So we know that minus B is then minus 8 over 2A. So it's 2 minus 2 times minus 1. Sorry. So it is 8 divided by 2 or minus 8 divided by minus 2, which gives us 4. Okay. And that is actually your answer. So it's in this one, it is nearly to recognize that from your marginal revenue equal to marginal cost, that is where you aiming to get to, but to work that out, you just actually need to get to what is the turning point. And when you look at the turning point, so let's say I'm now gonna let's let's just make some kind of graph here. So let's say that was the turning point, or that was the rest of a graph. So they asking you how much units, the quantity. They're not asking you the price, but if they needed to know at what price, you could have then put that for back into your formula to get to the price point as well. So if you needed to get the pricing of that unit or where it maximizes it, you could have just then put that for back into it. So let's do it. So just for in case that something like this does get asked in your paper, then at least you know. So 4 times 4 is 16. So it will be minus 16 plus 32 minus 12. Fascinating. 28 minus 28 plus 32. That is tricky, but so where a unit cost 4 rand, at 4 units, that is nearly where it would have maximized the profit. Okay, so that price could now have been in thousands or something else as well. But that is nearly, that is 16. It just feels weird that we're getting the same answer. 28, yeah, okay. So it is the same. So if I would have asked you in the exam to nearly look at what the price is at that profit point, then that is how you would have calculated it. Okay, so just something added to this one if needed, but else we would have stopped at that point. Okay, questions on this one? Let's go to the next one. So before we go to let me put it here, but when you did your assignments and the mock exam, was it very similar type of questions as to what we are going through now, or very different?
John, did you not get my email?
Oh my word.
I sent to
No,
your Gmail. I sent all of the assignments. I sent it on Wednesday already.
I didn't get it.
Maybe it
That,
went to your spam.
okay. Okay, so I will then go and look at that. I did not get anything. So yeah, that's I knew you told me you're sending it to me, but I have not received anything. So it might have gone into my spam folders.
Unless I spelled your name incorrectly, that's also another
That can also
possibility.
be because that could be likely as well. So let me. So yeah, so I'm gonna. You can send it again, and then to my Gmail. So now it's just easier to copy it out of this one. It's now in the chat. Then you can. We still have a day or two that I can look at it and and see if there's anything weirder out of it. Um, then yeah, so but was it so is this while we're now working through it, does it feel different or does it feel like the same tone of questions?
These ones feel easier
Okay.
and
It
simpler.
feels different, to be honest. I don't remember seeing this question.
Okay, that is fascinating. So,
No, they were
re-
maximum minimum values.
see, so your, to be honest, and that is especially for this, your assignments normally is more difficult than your exam, um, because they nearly test a bit more. So they nearly want to push the limits with the assignments where they won't do in your exam. So that is one of those things that you will really get weird things in assignments, um, or things that will take longer to calculate, um, just because um, they nearly testing the boundaries with some of the assignments. But interesting, then the mock exam should have been much more in line with where I now got it. Okay.
Sorry, I saw it was an extra M that I missed out on.
Okay.
But in terms of the mock exam, actually there were a lot of questions out of the assignments that were in the mock exam, which was quite interesting.
Yeah. See, so what they
You'll see like a lot
do,
of repetition there.
I see, so there's also the marginal cost for every, yeah, I see, so, yeah, so what they, and that is nearly, oh, there's very elasticity stuff. So what they definitely do is, and that's why always when you get previous, if you get previous exam papers and things like that, they love to ask previous work. It's just so much simpler for them to nearly use previous things. Um, so that definitely, so that is why in the mock exam as well, they probably used a lot of the previous, and because you needed to do it. Um, so when you are forced to do a mock exam, it's normally just a copy and paste of previous assignments. Um, because if, and I think last time you guys said there was an extra assignment that you didn't need to do, um, which probably would have been a very nice example of your actual um, exam, because they know that most of, let's be honest, anybody that are given an opportunity not to do one of those things will really not want to do it. Um, and and it's actually sad that it's not open now for you guys to actually test um, nearly now if you would have been able to do that other assignment. So yeah, so that is interesting, the difference in the two. Um, but but what I've seen in previous years, the exam paper feels a bit simpler, um, because they in the assignments they really test you on things that, yes, it is in the book, but it takes it to the next level. Um, yeah, so because this was also 2020, this was also one of the for online exams. So it's not that it wasn't an online exam. So it was already then moved into the online environment, which is also interesting, the big difference that you guys are feeling in the two. Okay. Okay, so let's continue. I now have some of those, so I'll scan through them over the weekend. Well, today and tomorrow. Um, let me quickly. You guys are writing on on Tuesday. I don't know. Will it check in on Monday evening? I don't really. At that point, I don't really want to add confusion to the. Would you like a hour session just as a check-in on Monday, or rather not? I know it is. I didn't like to have anything a day before I'm writing, because then sometimes it confuses me. So, but if you guys want to, I'll organize something. Okay. So I'll set up a session for us on Monday, and then if you want to be in the session, you can. If you don't want to be in the session, that's also fine. Don't because I know I normally didn't want to have a session before, um, but I will ask them to create a session for us on Monday, just as a check-in. And then I will check some of the assignments. I'll scroll through yeah. I also, it will probably just be for an hour or so, from 8 to 7. I'll just want to check my load shedding schedule, that but it 8 to sorry, 6, not 8, 6 to 7 will probably be a good time. But I will let you guys know that what time it will be. So I will, let me just add. So if you're not on the WhatsApp group, here is the number again to send me a WhatsApp, then I'll just add you to a WhatsApp group. But I will then message you nearly to say, it will be 5 or it will be 6. And but I also think 6 to 7 is probably a much better time, just as a final check-in. Okay. I will set that up for us, so don't worry about that. Okay, so then let's look at the next question. So here they're asking us again, find the values for x that maximizes. Okay, so what's the first thing that we need to do when we maximize? Okay, so when we maximize something, it's like what we did here. We would have said that we need to, here we don't know what the formula looks like, so we need to basically differentiate that. So when we differentiate that, what we do is basically saying 3 goes to the front, 3x, 3 minus 1, 2 goes to the front, 2 times 3 is 6, and what's left is that. that should be equal to 0. So let's just write that out. So that should be equal to 0. But then you can also see, but let's first simplify a bit more. Okay, so we can take out 3x in both. So what is left is x plus 2. And then 3x must be equal to 0. So you can do it this way. 3x must be equal to 0, but also x plus 2 must be equal to 0. So x is equal to 0 is for one option. Let's see. Okay, so one of those two. And for other one, x is then equal to minus 2. Okay, so there we have option 1. Let's see, how did I get to... Phew, that's an interesting one. Okay, so by some, maybe because you're sitting here with a 3 and a 6, that's how they got to those two. But yeah, so by just looking at these options, you can see that if you again just set x plus 2 and you used the 2, there would have been a option for you as well. Okay, so by basically doing the differentiation of that function, we're looking at how we can maximize or minimize the value. Okay, so let's go to the next one. So you would nearly see the last few questions had a lot of differentiation questions in them. So let's see what we're talking here. So total cost, they give us, suppose the total cost of manufacturing tennis balls is given by that, where Q is the number of tennis balls manufactured. What is the marginal cost when Q is 20? Okay, so how do we get marginal cost? We basically,
Differentiate.
awesome. We differentiate total cost. So when we differentiate that function, we get 2q to the power of 1. Remember that one then goes over to there. Minus 4 will be your function that you work with. Then we can put in 20 into it. And then it is 40 minus 4, which will give you 36. Okay, so if you just put in 20 into this function, luckily it would not have worked, because then it would have been something like 400 minus 80. So at least there would not have been an answer for you to get to. Normally they do, one of our options is that they would just have it that if you put in this into a regional, there will be an option as well. So I think in this instance, luckily, And I think that is probably also why you guys feel this is very, it's in a sense simpler, because you're working with a very easy nearly equation here. But what they wanted to test is if you know that how to get to that marginal cost. So they tested, do you know how to get to the marginal cost? That's all that they didn't want to catch you out with a difficult formula or anything. They just wanted to know if you know what the basics is to get from total cost to marginal cost. And I think that is nearly, if you follow the pattern through this whole exam that was in 2020, it is nearly, it's testing your basic understanding of a subject. And I think that's why it will be interesting to go through your assignments to see where there's certain things that are different. Because again, in the exam, I want to test your basic knowledge about the subject. So yes, it is sometimes that your assignments are a bit more difficult than your exam would be. Okay, so let's go to the next one. Okay, so this this one is a bit difficult, or more difficult, or so find the derivative of this function. Phew. Okay, so when I look at all of those, okay, so let's quickly see they've got three terms. So it's basically with that multiplied in, and that one. So they're gonna split it into those terms. So let's let's multiply that in so that we can see what we have. So that's x squared. We multiply that in. It is, remember, that is basically, I put that's x to the power of half. So if I multiply that in, it is x to the power of 5/2. And then I still have this thing of x/1 plus. Okay, so that is nearly the formula that I'm going to work with. Okay, so I want to nearly simplify certain things. What we could have done with this as well is to take it to the top. But let's first do the others and see what we get, and then maybe cancel out some of the answer sets. So differentiate the first one. It will be 2x. Okay, so 2x, 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 2x. Okay, so could not eliminate anything yet. Okay, the next one, bring that forward. 5/2. Then it's x. What is left? So I need to take away one of the 2. So what is left is 3/2. So let's see. Okay, 3/2. So that, yes, it could have been, but it's, where's the 5/2? So it's not that one. Okay, so option 1 we can eliminate. 5/2, yes, but we're not adding, so that we can eliminate. Okay, another way to write this so that we get to what these two are. Okay, so that was another way to write it. Okay, that is also not always needed, as in that case, it can disappear. So that is the right one. That is not the right one, so option 3 is going to be our right answer without even looking at this component yet. We could have decided which one it is, but let's work this one out separately. So what I would have done here is, let's keep the X. I would have brought that up to the top because then it's easier for me to work with. Then it would have been -1. Okay, so then if I look at this one, what would happen with the X? It is 1. What would happen with this one is that it's -1, -1, which gives you -2. And then if I put that back into a fraction, it would have been 1/. Okay, and that would have been then similar to that one. Okay, but again, in the exam, to save you time, I would really do it step by step. And then by this stage, I nearly could see, well, I've eliminated everything except one. So then do I really need to go and work out that last one? And that again is I would again, I would try to do it as simple as possible for myself. So, but again, you guys can decide if you want to nearly go the extra step just to check. And it might also be that you mark it and say, okay, let's, if I have time towards the end of the paper, I know I'm going for free, but let's just then later on check that last spot if you have time. Okay, so let's then go into question 26, which is integration. So how would you have done this part? How would you have done this? Oh, you are allowed to use online calculators, eh? I'm just now.
Yeah, I checked that like a month or so ago, and the lecturer said we can use Excel or online calculators. Shouldn't specify.
Okay. I'm just
But then,
thinking.
but now in the last
Yes.
like while, I mean, they keep saying things about the proctoring tool, and we mustn't. I don't know.
Okay, so for that tool, what it does is it nearly wants to make sure that you don't cheat by having somebody else doing it for you. So when you're writing your exam, and that tool is on, please make sure that if you're writing it at home, that there's no family nearly in the background or things like that nearly, unless it's far off. But please, somebody must not bring you coffee while you're writing exam and then it picks up any of their face or anything like that, because then it the, they think it's somebody that is assisting you. Um, the same nearly, and I know it's very difficult, especially with all the load shedding. But a place like an internet cafe where it can pick up a lot of the noise, sometimes is also quite the issue with a tool. But it's okay for you to have a lot of books around you when you're writing. It's okay for you to have calculators, to have your internet open, to have online tools open, to have Excel open. That that is fine. It should just not be able to pick up people that might be walking around you. So again, sometimes when you're writing in an office environment, if you're using the office as, nearly try and get an area where it can't pick up, if it's possible. Again, I know it's very difficult at the moment to nearly get to places where you don't have load shedding and you don't have certain things. But with a tool that is nearly, so it won't penalize you for opening up Excel or opening up a online tool or things like that. Um, please don't open up WhatsApp on your if you, because you need to work through, I think, a laptop when you do it. So don't open up the laptop version of WhatsApp. I don't know what it is capable of looking at chats or things like that. So please just don't chat while you're on your laptop doing the exam. But if you open up the integration tool, since they said you are allowed to, that is actually fine. So you can do that. So all that Anna did, so let's Google something. So let's say you need to evaluate the integral. So what do they, so there was one. The Wolfram Alpha one is a very, very familiar one as well that they use. So let's see if we can. So I want to use that one. Okay. And then I just want to see where's the DX component. Why don't I see it now here? But we'll get to that now. So from 4 to 0. They even give us some previous. So let's see if we can use that one. So again, if you can use these things, by all means do it. I just now to see where is where is the DX component to that? Can I do that? Will it see it as, let's say go?
Would we be able to use this sort of thing?
Yes, you are. So,
Really? Well,
so,
ahead time.
so that is why it's nearly, I want to get to this one. So I just wanted to get to that. So you are allowed, because they said you're allowed to use online calculators, you are.
Okay.
So I just want to, so for this one, please use something like this, if you can. I'm just trying now to see where I
I
wanted.
just have a quick question. I read
Yes.
somewhere it said that we're not allowed to minimize the screen. For instance, if you're using your laptop, then you're not allowed to minimize it, sort of leave the exam. It's sort of like leaving the exam. So I'm not sure. Are you supposed to use the calculator on a different
S-
laptop or your phone if you're writing on your
So,
laptop?
so what, so as you, yeah, so I think that is important. So what you can do is, um, it, it nearly, so when you don't need to minimize that screen,
Mm-hmm.
um, it, you can just open another screen over it. Because what it will do, and I think it's using the camera to nearly look at you and look at, so you can have multiple
Mm-hmm.
screens open on your laptop, but never nearly minimize that your the one that you're writing with, because that's the one that nearly the whole time picks up everything.
Oh,
If
okay then.
that makes sense. So,
Yes.
um, so again, ideal world, you have multiple screens and all those kind of things. It
Uh,
is not possible to be in an ideal world in
mhm.
our environment. So, by all means, you can have multiple screens open. But yes, your original one that you're writing with, whether it's Invigilator app or whatever they call it, is on that one, you need to nearly keep open the whole time.
Okay
Um,
then.
yeah, and what that also does, it it focuses more on you as the person that's writing it. Um, that's why they ask you nearly to, you would have needed to register for it with your face and those kind of things, because that is what it's nearly tracking the whole time, is to see that it is actually you that's writing the exam. So that's the big aim of it.
Okay.
Okay, so go and try and test this with the calculator. The answer should be 8,67. I just want to get that we do the other stuff, and then we can get back to this one in any case, so that I will show you, if we don't use for online calculator, how to do this one as well. But let's quickly get through to the other ones, and then we can get back to that. Okay, marginal revenue functions of a monopolistic producer is, phew, what, and yeah, okay, so determine the total revenue function. Okay, so how do we go from marginal revenue to total revenue?
Is that not integration?
Perfect. So we need now to integrate. So when we integrate, remember that, okay, so we're going to do a few things here. So from 10, we integrate, so it is 10q. There is a 1 that you would divide by 1, but that is basically one can leave that out. Okay, so 4q, so where it was 1, that becomes 2, because it's 1 plus 1, but then we need to remember to divide by whatever there is. And remember, just there's always a constant, because there is probably a function where there is a fixed cost that we need to add. So that is normally, the C is normally the fixed cost component. So whenever you nearly see something in here, or they tell you there's a fixed cost, that is the C value that you can add. So yes, there needs to be a C everywhere. There will be free terms. So that one we could have from the start nearly also eliminated. But let's see if we now 4 divided by 2 is 2. Okay, so not that one, because we need to have 10q. Okay, so here we have option C. Okay, so again, what you would see, it's not that difficult, but you need to know that what you need to do with that marginal revenue curve to get to your total revenue function. And again, if you did something wrong in this instance, you would get that question nearly wrong. So you nearly need to know that you need to integrate your function to get to your total revenue. Let's see, could they then, I don't know if I could ask anything else on this to make it, if I could ask you quantity or anything like that, probably not. So that is nearly where it would have stopped. Okay, so let's just look at, okay, this, okay, it should have been, I'm now, okay, use question 27 and 28 is based on this function. So let's just, that was MR was equal to, let's just check, 10Q minus 4, or sorry, 10 minus 4Q, and total revenue we worked out now as 10Q minus 2Q2 plus C. Okay, so if we have the marginal revenue, we've got the total revenue. How do we determine what is the demand equation? Okay, so remember, total revenue is equal to price times Q. So we've got the total revenue of and we just divide by Q. Okay, so we could have at the top have said, okay, let's take out to Q. Let's just see, that is 5. This is interesting. That hmm, okay. So 2, 5 minus Q. Okay, they didn't do that. They didn't take out the 5 as well. So we just sit with this. Interesting that they didn't take out the 2. I thought they would have done it like that. But obviously there you can see if you didn't divide by Q, that is what you nearly would have gotten as one of the answers. So if you didn't divide by Q, that is what you would have gotten to. If you use just your previous marginal revenue, you would have gotten that. And if you only used the 4Q in this one, you would have used that one. So yes, there is, again, what they testing is more your knowledge than anything else in this one. So again, nearly from first principles, that you know what total revenue is, how you can use it. Problem is, if this one was wrong, the probability is very good that this one would have been wrong as well. So if you got this one wrong and said it was any one of those 2 or any one of those 3, you probably would have gotten this one also wrong. So unfortunately, again, the one that nearly follows up from the other one. Okay. So a firm's production function is given by this function, where Q denotes the number of units produced and L the number of laborers. Determine the size of a workforce that maximizes output. Okay, so how would you do this? Anybody, what would you do in this instance? And so let me, yeah?
Perhaps we want to find the derivative of the function.
Okay, cool. So that we will do. First, if you look at, so let's just cancel out a few things. Denotes the number of units produced and L the number of laborers. Okay, so let's look at that one. You can't have negative laborers Okay, so that is one of the things. You can't have negative laborers and you can't have a half laborer. Okay, so just by nearly eliminating, we could have eliminated two of the options. Then there was a minus 20. So in the exam, if it was me, and this is one of the last ones, I would have said, sure, minus 20, there's a 20. I would probably have gone for option 2, because why would they give me a negative value as well? That is what I would have done. But how would we do the derivative of this function? Now we need to. Okay, how would you derive work with this function? Just quickly want to check. Do that. Okay, so anybody, if you had this in the exam, what would your first thing have been that you would do? Okay, so how do we? Let's work with that one. That one first. How would we work with that? What will that derivative be of that part of the equation?
Well, I just put the derivative function of this in a smart calculator.
Oh, can you do that?
Yes.
And your answer was 20.
Yeah.
Oh my word. Okay, so see again, Robin, why you are allowed then to work. Let's see. Why you allowed to use these kind of things online? Because there is, oh, it gives me the same. So wait. Let's see if I can. So we in the same. So this one is actually a very cool online calculator. The Symbo Lab, if you want to use. I just want to see if it will pick up. Oh, it will pick up the E. It actually does. Okay, so now I need to say to the power of. So will it do that? Yes. Okay. I must still go and. So please go and play with this. It gives you. But why doesn't it give you the answer? Or did I now miss it in there? is for 20. So it actually does the whole graph and everything for you. Oh, this is, yeah, so please go and look. I'm going to copy this so you can just look at. Okay, so it's in the chat. Let's just see if it does verify the link. Okay, and then you can go and say which one you want to use, because yeah, it's the same as the smart calculator. So you can, and that's why, again, your online calculators are available for you, because if somebody, they won't be able to track what calculator you're using. So that's nearly why they also allow you to use the online calculators. See, again, with this one, if you don't know what to do, it in any case doesn't matter if you have an online calculator or not, because you needed to know that you need to get the derivative of this. No calculator is going to just say, here's the question. You still need to know what instruction you need to give to the calculator. And I think that is why, again, why there's no issue in using a smart calculator, or one of the online tools like the link that I've given in the chat now, because again, you still need to know what to do with that. Okay, last one. So a group of inequalities. In the graph below, the following set of inequalities was drawn. They tell you that's the feasibility region. Determine the maximum value of a revenue function. And then they tell you the maximum revenue is equal to one of those. Okay, so what you nearly need to do, so we've got that point, that point, that point, and that point to work with. So if I look at that point, I know that is going to be 0 and 0. So if I put in 0 and 0, my maximum revenue is going to be 0. So it's definitely not that point. If I put in A, that point would have been X is 0, Y is 8. And the reason why I can say Y is 8 is if I look at this formula, 2y was 16. So if I divide by 2, y would have been smaller or equal to 8. So I know that is 8. So I can put 8 in here. So if I put 8 into this, that is 0. 5 times 8 is 40. Okay, so one of the options that I get is 40. Let's look at this point. Here I see 3y smaller or equal to 45. But 5x 45, so I know that x value is 9. The x is 9, the y is 0. I put 9 in here, gives me 18. 18 plus 0 is 18. So 18 and 0 is not going to be the 2. And then if I look at that point, okay, I can guesstimate it's going to be about 5 each, but I'm not 100% sure. So I just need to first work out what that point is. So that is the point of 5x plus 3y is smaller or equal to 45. And the other one was x plus 2y smaller or equal to 16. So I nearly need to calculate that point B. Is the easy way. Okay, what's the easiest here? To say, okay, I multiply the bottom one by 5, then it becomes 10, 15, 16 times 5 is 80. Okay, so then I say this one minus that one, so I get 0. This minus that is 7y. That minus that is 35. So y would have been 5. I put y back into here, so I can say 3 times 5 is 15. 15 to this side makes it 30. 5x is 30, so x would be equal to 6. Okay, and if I then put that into that function, 2 times 6 is 12. 5 times 5 is 25. And I get 57. Okay, which is also a point on the graph or one of the options. So which one would you pick? 40 or 37? They tell us which one we want to maximize. So 40 is bigger than 37. So the option that we will go for is option 1, the 40. So interesting, you actually got 2 of the answers in the answer set. But what is important, you want to maximize the revenue function. So for that function that you want to maximize, it will be that point that will maximize it, point C, which is 40. They can also ask you to, instead of saying the value, they could have asked you which point will maximize your revenue function as well. Okay, so that is it. So I will get Bronwyn and the team to set up some time for us on Monday evening, just as a final check-in for you. But it will, I think, let's just make it an hour session. I'll go through some of the assignments that Robin sent me. As you go through things this coming weekend, still as you prepare, and you see something that you're not sure of, put it on the group, or you can send it to me. I will then just add it onto a PowerPoint to go through. Otherwise, we just on Monday evening can just have a check in and chat if anything else that you picked up while you prepared. Okay. Okay, so that is that is it for today. Good luck.